In the last video, what we looked at that when I look at the negation of P here, which is equal to saying Q and not R. Well, by using proof by contradiction, this will always lead to some kind of a contradiction, right? Which could be written as Q and not R. If Q and not R, then some kind of contradiction, which happens to be false. And because of this contradiction, we said that P is actually true, right? Because of this contradiction, we said that the statement P, which is basically if Q, then R, is actually true. Okay, so what is it in the statement that when it leads to false, it allows us to come back and claim that the original statement of P is actually true? Well, let's check this using a truth table here. So if I create a truth table for Q, R, and this is if Q, then R, and let's create one for not R, and let's create one for Q and not R. Okay, and finally this entire piece over here, let's just put this in yellow, box in yellow, and because I don't have space here, I'm just going to put that box, same box over here. Okay, so Q and R is 0, 0, 0, 1, 1, 0, 1, 1. This gives you 1, 1, 0, 1. Not R gives you 1, 0, 1, 0. Q and not R. Q is over here, not R is over here. So 0 and 1 gives you 0, 0 and 0 gives 0, 1 and 1 gives you 1, 1 and 0 gives you 0. And this box over here, for this box, because my conclusion is always false, then Q and not R. So this is going to give you, let's put this in yellow, this is going to give you 1, 1, and 1 and 0 gives you 0, 0 and 0 also gives you 1. So concentrate on this column here. This column here and this column over here. Now the last column is basically a proof by contradiction. This is your proof by contradiction, right? And by using proof by contradiction, you can see that the entire column is completely exactly the same as this column over here. So by using proof by contradiction, we're technically proving the original statement P, which is if Q, then R. And this is the intuition that I would like you to keep in your mind when you're solving problems, when you're solving these theorems, and you're trying to prove these theorems, and your approach is to use proof by contradiction.